Technology usually advances in small steps. But there are fields in science and engineering which are on the brink of making giant leaps that could change the world in dramatic ways. One such field is quantum information, a technology that many countries, including China, are now racing to develop.
Our quantum computer system can do something much faster than the state-of-the-art supercomputer. Quantum computer will be a standard tool for all scientists. Our technology could be used for many, many other fields. I am Jianwei Pan. My major focus is in the field of quantum physics and quantum information. I would like to give a short example to explain the strangeness of quantum mechanics. So suppose you have two entangled particles, then when they're separated, as long as these two particles are entangled, then this state of one particle will be transmitted to the other one, so it will be a perfect correlation. If you do this in the laboratory, so they are so close, then maybe they have some sort of interaction. But the thing is, the degrees of the distance, they are separate far, far away. And you will see, as long as this particle is in a state of 1, then the other one is also in state of 1. If this one is in state 0, then the other one will be in state 0, no matter how far away they are separated. So this is a weird thing of quantum mechanics. So people keep asking, why could it be like this? I really want to understand. But whenever you read more, you are more confused. So that's the real problem.
In an attempt to better understand quantum entanglement, Jianwei Pan and his team came up with a bold experiment to see if entangled particles would remain entangled when over 1,000 kilometers apart.
So the basic idea is we have entangled photon source installed on the satellite. So the satellite will send two entangled photons to two ground stations, which are separated with a distance on the order of 1,000 kilometers.
With ground teams waiting at observatories spread out across China, the group held their breath.
Our expectation is 99.9% quantum mechanics is still correct, but still is 0.01% or something like that. So we want to see some deviation. Then we really find something great. Then people need to reformulate quantum mechanics.
With their satellite in position high overhead, the team prepared for their historic experiment.
We have to solve lots of problems to make sure the light is always pointed into your eye from the sky. We have to develop lots of advanced technology so that we can send in the two photons precisely to the two ground stations. Then afterward, we perform measurement on the received single photon. So in our experiment, we managed to show this strange phenomenon over a distance about 1,207 kilometers. So it's really far away. This is a phenomenon in nature, but we don't know why or how this happened. But we are super happy because our technology could be used for future application of quantum communication.
And the application Jianwei Pan and his team chose to attempt was to harness the long-distance quantum entanglement they'd observed to create an uncrackable encryption key.
So another mission for the satellite, we think we need to use entanglement to encrypt your message, your picture, or your video. So therefore, in 2017, we managed to ensure the secure information transfer over a distance of 7,600 kilometers between Beijing and Vienna. for a video conference between both president of China Academy of Science and the president of Austrian Academy of Science. So you first generate a secret key, then you perform the encryption to send you video message. So he is the only person who can read out this secret message, no one else. And actually, if you have eavesdrop is some sort of measurement. So if someone measure in between the content channel, then the state will be changed by the eavesdrop. So you know there's someone already perform eavesdropping on your key. Then you throw away the key.
This emerging field of quantum information promises radical changes in society, perhaps eventually powering a revolution in computing as well.
In the digital classic or modern computer, the basic information element is a bit. So for each bit at a fixed moment, it can only be either in 0 state or 1 state. But however, for a quantum particle, a qubit, then it can have 2 states memorized in the same bit or same qubit simultaneously. But now if we have 2 quantum bits, they can be in the position of 0, 0, plus 1, 0, plus 0, 1, plus 1, 1. Then you already gain a factor of 4. So then if you increase the number of qubits, then you really gain enormous computational capacity.
By scaling up the potential for doing calculations in this way, with just 50 qubits, you get more possible combinations than there are atoms in the universe.
This is precisely the reason why quantum computer can be so powerful. Its computational capacity for some specific task can be, I think, 1 million times faster than the total computing power over the world today. Of course, it may take 30 years or even 100 years to have a universal quantum computer like we are using today. For the whole quantum technology field, we are still at the early age. But I think the race really already started.